Right, so let's just go through it. And I'm going to take a bit of time, even though we have the right answer. So, by the way, one of you has the right answer, the rest of you cannot claim to have the knowledge. Should we make that very clear? We all still need to go through.
Courtney and I were close.
Right. I would like, please, so everyone, can we explain the cross multiplication thing? Right. Now, the whole point of cross multiplication, I'm going to do it in maybe a way, I'm going to just do it quickly first, so you probably will recognise it. So, when you cross multiply, so I'm going to, because I've got an equal sign, so I go across the equal sign, what happens is, I get the 22 plus x times 2, so I've got 2 times 22 plus x, okay, and equals, now that gets multiplied by 1, so I end up with 50 plus x, okay. Now there's two ways to think about this, so I would like to explain that to you, please. So, one way to think about it is this. If I've got this set up, and I want to solve for x, what I need to do is try and get x's in a situation where I can start eliminating them. So what I'm going to do first is I'm going to try and eliminate the x in the denominator, and the best way to do that is to multiply both sides by 50 plus x. Right? I have to do it by the whole thing in the brackets. So what I then end up with is 22 plus x times 50 plus x, right, all over 50 plus x, and that equals a half times 50 plus x. Are you okay with that at the moment? The multiplied by both sides. Now the effect of doing that is that this 50 plus x can cancel with that one, because 50 plus x divided by 50 plus x is 1. So because I have a factor here, there's a multiply, it's a common factor, so I can get rid of it. Now, on this side, instead of writing times a half, I'm going to do it, so I'm left with 22 plus x. This, instead of times a half, I'm going to now write it as 50 plus x, but all divided by 2. Are you happy with that? Yeah. What do I do to get rid of the time divide by 2? So I times by 2. Alright? Which gives me that undoes that, and I get left with 44. Yeah, come on. It's going slow. So it becomes 44 plus 2x. Come on. Back. So, what I would like to do though is let's just have another think about what cross cancellation actually means. So, going back to the, what was it? X plus, sorry, 22 plus x over 50 plus x equals a half. Now another way to think about this, and this is quite useful to you, especially when dealing with logarithms and things like that as well, right? How do I've got an equal sign, and that means what's on the left has to equal what's on the right. Now if they are different, I've got to do some thinking, but what happens is, if I make the denominator the same, then the numerators must be the same as well. So what I can do is try and find, as you've done before, a common denominator. And the easiest way to do that is to do what? So I could multiply this one by 2 and this one by 50 plus x. But then what do I have to do to keep the fractions the same as they were to start with? I have to do the same to the top. Okay? So what I'm doing now is it is still cross multiplication, but it's going at it in a different method. So what I end up with now is 2 times 22 plus x over 2 times 50 plus x is equal to 50 plus x over 2 times 50 plus x. Now this is the point at which there's no maths necessarily, but a little bit of understanding. If my two denominators are the same, I don't really care what they are. If they're the same, I know the tops, the numerators, must also be the same. So I can actually kind of just forget that they even exist and just look at the tops. Does that make sense? It's like saying if I've got a over 3 equals b over 3, you know that a must equal b regardless of what 3 is, yeah? Right, so I'm doing the same thing. Now you'll notice that we end up with the same situation, 2 times 22 plus x and so on. Now what people do as a shortcut, when we start with 22 plus x over 50 plus x equals a half, they just do this. They say that goes up there and that goes up there. Alright, and they move things around. But in actual explaining terms, sorry girls, I'm boring you.
Oh, I just don't understand it.
Well then pay attention.
I got lost up top.
Well, ask me. You can't switch off and start looking through your agenda instead. I will assume that you're not interested. Let's move on. So that's the cross cancellation thing. I hope it made a bit more sense to you. Alright?
Those are the same thing?
They're all the same thing, yeah.
Like those two exact things, just that when you decide to write the two correctly.
Yeah, so I would end up with 2 times that equals 1 times that, and I end up with the top look. The 2 goes up there to make the 2 times that. This goes up there to make that, and because the bottoms are the same. But here it's like, you understand how people would say pick that up and move it over there. Pick that up and move it up there, but that's not what's actually happening. It's a shortcut to help people that look at their planners instead of understanding do it.
Wait, but why don't you times the bottom?
You
Pardon?
do, but we just get
You
lazy
do,
and
but
don't
it's
write it.
but
Yeah.
it's by 1, so it's gonna
That's
be the same.
exactly. I think that's the thing. It's
So how's it by 1? Wouldn't it be 50 plus x times 2?
no. So the 2 would end up being multiplied up here. Look, 2 times, and this one gets multiplied by the 1.
I get that.
Yeah.
So that wasn't my question.
What was your question? What was your question?
Everyone else thought that was your question.
I get that, but we've always done that and the bottom.
Well, that's to get a
That's
common
right.
denominator. That's
Yeah.
a common denominator. That's something different, Harley.
Wait, but you did do it to the bottom as well, didn't you?
Yeah, up here. Look.
Yeah, apparently you don't have to do that anymore.
No. So what I'm showing you.
Is that's what like actually happens? Because I actually never knew that there was a. Okay, he was saying that like
It's not
It's-
just a step that you do.
yeah, like you don't just
Yeah.
have it. Like that becomes 2 multiplied by 50 plus x, but because it's the same on each side, we just cancel out. Which is why people like us don't write it because
Oh, I write it.
So this step here, once you really, what should happen is we should start doing it that way. And then when you fully understand what's happening, then take all the shortcuts you like. Alright? As long as you understand what's... But the problem happens when you get taught and you get taught the shortcut as the maths. And you kind of then don't really understand the maths that's going on behind it. And then when things get more complicated and you really could do with understanding the maths behind it, it then makes everything else harder. Alright? Do you think that, you know, in a lot of algebra you have to understand what's actually being done because you can't just ignore that because it's now got letters involved, for instance. So to actually understand what cross cancellation or cross multiplying means, you can now work with it. Alright? So hopefully that opened up for some of them. So we've got that version, or like I said, the other way, which isn't on screen anymore, was to multiply and undo the division, and you end up with the same thing. Alright? But just to help you know, you can still do the move if that's what you have up in your head and you want to keep it that way. But just remember, you are not moving. Try and remember that you actually, there is a mathematical process to it. Okay? So, let's just quickly, I do want to move on. What about the 127 over 268? How would we do that? Let's do it together. 127 over 268. That has to equal a half, but we need to add the x.
Wait, do I have to do the full one or can I just do the multiply?
Whichever one. So we multiply by, so multiply both sides by 2 gives me the 2 times 177 plus x equals the 1. I've still got that, so I'm also going to multiply by 268 plus x, yeah?
What's 127?
Because by multiplying that bit, I then get this one over here. Okay? Got that? Is everyone with me? I don't want to lose anyone, because obviously Courtney knows what she's doing, so can I just get rid of this 1 in the brackets, yeah? Multiply out the other one, so I've got 2 times 127 is 254 plus 2x. Subtract the x, gives you 254 plus only 1x now. Subtract 254. So x equals 14. So we ought to be able to check, because it's always good to check, even if you only do it mentally, we should check that 127 plus 14 over 268 plus 14 does actually give you equivalent to a half. And what does it give you? So 141 over 282. So that is equal to a half, isn't it? So we've got that check. Right. Cool. I feel that was worthwhile. Now, back to binomial expansion. Yeah, you can't complain. When we do the next assessment, you can't say, but you never gave us any questions. You went through it. I'm giving you lots.
The other classes haven't started doing binomial expansion.
No. Yeah. So this means next time they're doing binomial expansion, we're going to be like the next subtopic ahead, and then we're going to be confused.
No, because we're going to have to go back to do logarithms.
Yeah.
So, yeah. Right. Here's a question for you. Again, I've got 2 questions. I think we did that one last time. So I've got this question. I've got 2 to go through. I'm just going to give it to you and see whether you can. What you can do.
Get that out of my face.
Can you like zoom it in? This isn't our past question, right?
Yeah, it is. Yeah.
This is some high level, right?
So, to do the 3rd term, we have, remember it's a plus b to the power of 8. So the 3rd term would be a times b, but it would be a to the power of 5 and b to the power of 3. Is that right?
No.
No.
6.
Okay. Just checking that you're paying attention. Right? Because the 1st term is a to the power of 8, b to the power of 0. That's the 1st term, which is where the 8, 0 comes from. So the 3rd term will be a to the power of 6, b to the power of 2, because it's got to add up to 8. So then we replace the a and the b with these 2 things. So we then have, instead of a to the power of 6, we have 2x cubed, all to the power of 6, multiplied by, instead of b, it will be b over x, all to the power of 2.
Do you do that to cancel out the x's?
So in this case, the x's will cancel, yeah?
That's what I was trying.
So the beginning will be 8, 2. That's the coefficient. So if I do this expansion now, okay, I'm going to leave 8, 2 for the moment because it's not as simple. But I would do 2 to the power of 6 alright, times x to the power of 18, and then I'm going to times that all by b squared over x squared. Now, because it's all divided, it's all multiplied, divided by x squared, the x squared can cancel with these x's. So this would become x to the power of 16. Alright? Does that make sense? So I would be left with just whatever this value is, times 2 to the power of 6, times x to the power of 16, times b squared. That would be all. Right? Now, if I go back up to what we were doing in the one we actually want, look. So I know that the second term is, what was it, 3072, is it? 3072. And it's x to the power of 20. Alright? Now, if I find the second term, so I know it's 8,1 because it's the second term. I know the a bit, the 2x cubed is to the power of 7. The b over x is to the power of 1. The reason is then, so if I expand that, 2 to the power of 7, 8,1 is 8. This x cancels with one of those x's. Now that gives me the x to the power of 20, so that's covered. Because this x divided got rid of one of them. So now I've got a times b. And all of that equals the term that I know is there. Alright, I know what it should be, I've just got to get to it. Now, if we then look at what we've got, what is 8 times 2 to the power of 7? What's that bit multiplied? Can you do that for me on your calculator? Pardon? 1,000 and... Okay, so I've got 1,024 x to the power of 20 times b. That is going to equal, alright, because this is what I was told it was equal to in the question.
Right.
So what can I do at this stage?
Find b.
Find.
Cancel out the x's.
So I can cancel out the x to the power of 20 because it's on both sides.
And
So
then-
now I know that 1024b equals 3072.
Divide by the 1002.
So b is 3072 divided by 1, and what do I get?
3.
3? You get something wrong in there. So b is equal to 3.
Yeah, that's right.
B is equal. Oh, we divided it. I divided it. I subtracted it instead of I should have divided it.
Well,
Okay.
It's not what you do. It's yeah.
Okay, so the second part, which is supposed to be quicker, you'll notice that I've replaced the b with the 3 value you've got. So obviously if you did part A wrong, this bit might be, well, you're going to be wrong, but it's actually
Is
not.
it 2?
do you get follow through marks in IB?
Yes, you get follow through marks. Lots more.
Wait, is
Right, so let's have a look. So the bit I've used here, the bit with the k, I've got to find k. Now x to the power of 0, well, we know that x to the power of 0 is 1, so actually this is the constant term. So we've talked about the constant terms. It's basically just a number.
Is that the 8 over 0?
It's not, no, because you'll notice it says it's not 2x3 to the power of 8. This is the whole expansion. It's not a term yet. This is the whole thing. Right, so basically what we're saying, everyone,
Constant
listen.
doesn't have like x.
The constant term will not have an x in. That's why it's x to the power of 0. So it's another way of saying it. Now, so what we need to do is we need to figure out, we've got 8 over something, right, has to equal 2x cubed to the power of something times 3 over x to the power of something else, okay? These two things have to add up to make 8.
Wait, do those two have to add up once it's multiplied by 3?
No, so now I split it to make 8.
2 and 6.
And then 3 times that one has to equal that one. Alright? Because this x is on top and this x is underneath, when they multiply, they will cancel each other out if they end up being the same power.
Wait, so it's a...
So what we maybe can spot straight away is if we do 2x cubed to the power of 2 multiplied by 3 over x to the power of 6, right, that would then make this 8 2. We would then end up with,
Wait, wouldn't it be 8 6?
Give me both.
either way, either one you want, we would then end up with 8 2, whatever it will be, and it will be 4 because of the 2 squared, x to the power of 6 because you multiply, multiplied by 3 to the power of 6 all over x to the power of 6. Hence the x to the power of 6's cancel out and you end up with the constant term. So we get 8 2, whatever that is, which you can find on your calculator, times 4 times 3 to the power of 6, and that will equal
81,648.
big number,
Okay, wait
which
a
is
second.
quite often the case.
Can you go back up again then?
I feel like a little genius.
Did that make sense to you? I'm recording, so at the end you'll know that this one, that's your homework.
Can you scroll up a tiny bit?
Have a go at it for homework.
Can you scroll up to the bottom?
So it's on the video, I'll post it on the blog.
Yeah, I have